Let's solve the step by step using de Moivre's theorem. To find 1i to the fifth power, we'll first convert 1i into polar form. Let's start by drawing the complex number 1i on an Argand diagram. Here are our real and imaginary axes. The complex number 1i has a real part of 1 and an imaginary part of -1. Let's plot this point. We can represent this as a vector from the origin to our point. To convert to polar form, we need two things. First, the magnitude, r, which is the length of our vector. We can find this using the Pythagorean theorem. R equals the square root of 1 squared plus 1 squared, which equals the square root of 2. Second, we need the angle theta from the positive real axis. We can find this using arctangent. Theta equals arctangent of -1/1, which equals -45 degrees, or -pi/4 radians. Now we can write 1i in polar form. The polar form is r times e to the I theta power. So 1i equals the square root of 2 times e to the -pi/4i. Now we can use de Moivre's theorem, which states that when we raise a complex number in polar form to a power n, we multiply the angle by n and raise the magnitude to the nth power. So 1i to the fifth power equals the square root of 2 to the fifth power times e to the -5pi/4i. Let's simplify this step by step. First, the square root of 2 to the fifth power equals 4 times the square root of 2. The angle -5pi/4 is equivalent to -pi plus -pi/4. This means one complete rotation clockwise plus another -pi/4, which brings us to the same point as just -pi/4. Therefore, our final answer is -4 times the square root of 2 times e to the -pi/4i. Converting back to rectangular form, this equals -4 minus 4i. And there we have it. We found that 1i to the fifth power equals -4 minus 4i by using polar form and de Moivre's theorem.